everybody. Welcome to Lambda Days. Right, I'm going to be speaking to you on how your docs are like programs. Now, I want you to imagine that you're not you, imagine that you're somebody else, and you're just discovering the joys of the internet. You know, not the vast amount of knowledge that's there, because, I mean, that's what we love, right? But things that you're really excited about are cat photos. Oh, there we go. This is a photo, it's not of my cat, it's of somebody else's cat, but it's a very cute one. So imagine that you love cat photos so much. You decide to write some code, your very own library, your first library, which is about cat photo albums. Here's what this code looks like in Scala. We have a case class for your album. You can add photos to it, and you can get photos. And it's basically just a map, right? There is nothing special about this code. But, you know, first open source library. In case you can't read Scala, this is some code. It's written in Elixir. Very, very same thing. So you're really, really excited, right, about this code that you've just written. So you get all your friends together, and you want them to go and browse cat photos too. So you get them all in a room, and you show them your cat photo library, and not surprisingly, they have some questions. They ask, okay, how do I get started, right? I really love this concept, but you know, I need to start using it, and maybe they don't code very much. Maybe some of them, they're actually dog people. And they'll ask, why? Why should I store cat photos at all? Why are cat photos special? Now, some of your other friends, they might be deep in the weeds. They might ask, or already coding away, ask, okay, well, I've put a photo in. How do I get it out? And some others, they might ask, well, they're looking specifically at this add photo function. What should they pass to it?
So
that's okay for your few friends that you have, right? Your few human friends in your room. You can just answer their questions in person. But over time, cat photos become much more popular, and a lot more people start wanting to use your library. And so at this point, you start thinking, maybe it's about time to write some docs. Now, there are actually different types of docs for different kinds of people, right? If someone's just getting started, they might want a tutorial. If someone is, let's say, they're already started and now they're thinking a little bit about what they should use the cat photo library for, they might want a conceptual guide. And then if someone's already in the weeds coding, they've got their laptop out, they might want something like a how-to or a reference guide. So you write different kinds of things depending on what people are doing.
yeah.
And people will be consuming that documentation in different ways. Most of the time, they'll be coding away, they'll be in their IDE, and that's how they'll want to see their docs. But sometimes they might be elsewhere, right? They're not on their laptop, they're on their phone or in some other place, and they'll want to be using a browser. And so because of that, you actually write different kinds of documentation in different ways. So let's say that we want to go and we want to document cat photo. There are actually tons and tons of different tools we could use. If we go and just search for documentation tooling, you'll find that there are tools specific to each language. There are many, many different flavors of Markdown, right? And markup as well. And there are site generators that you can go to and frameworks that you can use. And there's so much choice out there. So how do we pick which one? We're kind of inundated. We're already overwhelmed with the problem of writing documentation, and now we're overwhelmed by the tools that we have. So what we're going to do over the next hour or so is take a little step back from this problem and we're going to think about documentation in a slightly different way. We're going to think about docs as programs. And if we do that, I think we'll start to understand why there are so many different tools out there and what kinds of problems that they're solving and which ones are the right ones for us. So as for why I'm interested in this in particular, I really, really love functional programming. And I love teaching functional programming. I often encounter a lot of people who are very new to coding, very new to functional programming, and will be in the position of trying to explain concepts to them. I'm also a Scala ambassador, so if you want to talk about Scala, please come ask me questions. I'd be very happy to help you get started with it. And if you already work in Scala, I am your community representative for the Scala Center, so if you have suggestions on how it could be improved, you can come talk to me. Now, the thing about functional programming in particular is that some of the concepts that we try and explain tend to be very abstract. It's very, very hard to explain to somebody who doesn't have those abstractions as to why functional programming is important. Because often when they come and they look at, let's say, a functional programming library, it'll be so generalized that they can't really see how it applies to their field. And that's a bit of a barrier. Oh, as well as all of these things, by the way, I'm also on the program committee for Lambda World. So if you enjoy yourself here today, please consider going to Lambda World. And if you're considering speaking, the call for proposals is still open, so you can go and apply. I strongly encourage it. Okay, so we're going to have a look at how docs are programs in a few different ways. Starting with how docs are artifacts. So does everyone here kind of understand the concept of an artifact? Yeah, mostly. An artifact being, well, usually when we talk about artifacts in code, we're talking about something that we are going to publish to or distribute to other people. If we're on the JVM space, that might be a jar, or it might be a native binary. In the concepts of in the field of documentation, if we take a look at some of the docs that we might write, such as, for instance, so we want to write some reference docs for our photo functions, our documentation is actually taken and transformed in some kind of pipeline to produce something. So in this case, let's say we write some reference documentation, we might write that in our source code, and it will be transformed in some way to produce some API docs, which will usually be HTML, but also you can go and see those in your IDE. So you end up with some artifact of, in this case, HTML. And that's then used in your IDE. So we have a source, right? Our starting file, which had some comments in for documentation, our artifact, which was our HTML, and then we have some kind of a tool, which is the thing that browses that. And that's kind of similar, right, to programming, right, in a programming language. Kind of similar, except if we're working with an actual programming language, there's a ton of other stuff we have, right? We have a ton of validation. That's the thing that gives us satisfaction and gives us confidence. So maybe we could actually introduce some validation into our documentation. We're going to see some tools which allow us to do that. The first of those is doctest. So let's take a look at this documentation. It's not very good documentation, I'm sorry. It's documenting our getPhoto function. We've got some text which says, okay, this is what getPhoto should do. And now we have a code snippet which someone can hopefully go and take and paste, right? They can go and paste that into their own little Scala terminal, and they can start using and calling this getPhoto function. And we also have an example of what it should return, right? So if we put the photo of Mao, who happens to be my cat, inside our photo album and call get, we should just get the photo that we put in. So what doctest as a tool will do you integrate it into your build tool, in this case SBT, is that it will go and it will produce some tests from the code snippets that are in your documentation. So it will actually take this little block of code here, produce a test, and that test can then be ran. And so if we run this test, we'll see it succeeds. It succeeds because the things, the statements that we've said correspond, right, to the results that are written in here. Now this is really, really useful. Because if, say, we decide to change our function, let's say we change the type of our function now. Instead of just returning a string, if you've used maps, you'll know that maybe just returning the thing out of the map, that's not actually what you want, because what if our value doesn't exist? We decide to just return an option of string to represent the fact that maybe the photo for Mal wasn't there. We can easily do this, but forget to update our documentation. And if we do that, and we run our tests, doc test will help us, right? It will catch this, and it'll say, okay, well, we've got some failed tests. It will describe what the failure is as well. Now, that's really, really useful, right? That can be taken, that can be integrated now into your CI pipelines to make sure that your documentation is up to date. So if we choose to correct that, we can say now, okay, we're going to correct our documentation. It's going to say that we'll have a sum of mal, and maybe at this point we might want to write another code snippet, right, which covers the none case. If we run our tests, we'll see they succeed. Okay, so that's how we might want to document, or rather improve our documentation for reference guides. Kind of using the idea that there are bits of code within our reference guides. What about all the other stuff we write? Let's say that you go and you write a blog post, right, about cat photo now. How are you going to validate that? You're not going to write it in a comment for sure. So with the other forms of guides we usually write, we tend to gravitate towards Markdown. And that's for various reasons. Markdown has some great editors, and it's got some great viewers as well, right? If you use GitHub, you'll know that it's very, very easy to just get a view of what your Markdown looks like. So usually when we're writing all of these other guides, a lot of other literature around our library will gravitate to Markdown. And we'll have code snippets in that Markdown as well. So here is some code snippets showing how we get started with a photo album. And we can take a look at Markdown and the Markdown pipeline in the same way that we looked at our reference doc pipeline. So our Markdown file, it's a source file, and that's also converted into something else, usually HTML, which is then rendered, and it's rendered in a browser. So we also have this kind of, source to artifact pipeline, which means maybe we can also insert some validation, right? Well, it turns out you can. You can use a tool, if you're in Scala, called mdoc. And mdoc is something which will go and if you annotate all your code snippets with mdoc, if they're Scala snippets anyway, will go and run these snippets in an environment and get their output and plonk that back into a different file. So if we annotate all of this stuff with mdoc, by the way, what do we think is going to happen? Is this good code? It looks good, right? I think we've written it right. But actually, if we run this, we'll get an error. We'll get an error because album is not found. We haven't declared where it came from. Now, how many times have you gone to a blog post, right? Somebody's written, and you're trying to follow all the steps, and then you realize that actually, no, they're referencing some symbol. You don't know where it's from. You go and you search on Google, and you find that there are maybe 5 different libraries that have this symbol. It's very frustrating. Thankfully, with mdoc, you won't have that. You'll also need to do things like declare which libraries your symbols come from. So we can go and fix this error. We can add an import statement to the top of our post. And now if we run mdoc, it'll succeed. And it'll produce this output file. And the output file will have some comments inside corresponding to the actual result of our code run. So in the same way that when we were using writing our reference documentation, we were going and manually putting that in. In this case, mdoc goes and it puts it in for us. There are a few other things that it can do. It can do something called variable substitution. Oh, that sounds like a very programming language thing, right? But in fact, what that means is that you can write some stuff inside your Markdown files. In this case, let's say that what we want to actually do is version our documentation, as well as version it through some other tools like Git. We also want to insert the version number into our docs. Let's say cat photo evolves really, really rapidly, right? And we're on version 42, and we want our users to know that. What we can do is that we can write something between two double @ symbols, and mdoc is going to read this file, and it's going to say, oh, okay, we found these two @ symbols. That means someone wants to do a substitution. And if you pass in the value that you want to substitute, your output file is going to contain that value. So that's pretty cool. It's another thing you can do. And you can do that because we have this idea of this pipeline, right, of source to artifact, and we can do things in the middle. Well, what about output? So in our Markdown file, right, we have this get photo call, and it returns as mal.png. Wouldn't it be really nice if we could actually just display that, though, right? That's an image. Wouldn't it be nice for our users if they could see what this image was? But in order to do that, we're going to need to write some other code, right, to modify our pipeline. It turns out in mdoc you can do that. You can use something called a post modifier, and you can write your own, and you give it a name, in this case cat photo. And what that does is that it takes in the body of this code snippet, it gives you the value obtained by running the code snippet, and you can choose to do different things with that value. In this case, what we're going to do is that we're going to plonk a string back into our Markdown file corresponding to the URL that we got out of our code snippet. So the way that I use this is that I go and I annotate my initial Markdown file. I annotate the little snippets which already had an mdoc annotation with another one corresponding to the thing I want to do, in this case cat photo. And if I run this now, the code that I've just written gets run, and I get a little, this corresponds to an image in Markdown, right? Image of Mal. Which is really nice, right? So now we can actually not just have our documentation output be just comments in code that are the result of a run. We can actually display it in interesting ways. So hopefully you can see that by looking at docs as artifacts in a kind of very, a bit of a fuzzy way almost, we can start seeing how they're similar to pipelines in programming. We can start thinking about how to compile our docs, how to validate our docs and test them. We can also integrate these tests, right, and validations into our CI pipelines, which is great because it means that not only can we not break our docs, nobody else who's working on our documentation can break it as well. And we can just easily make code changes to our library without worrying about the effects of our docs. We can also do some more ergonomic things like variable substitution, so that we don't need to go and manually keep going and updating variables or things inside our docs. We can have tools which help us do that. And we can also manipulate the output to display it in interesting and creative ways. But there are other ways that docs are similar to programming languages. So docs are also trees, right? how are docs trees, right? Okay, so tree-like structures. If you think about the tools that we've seen so far, this is an example of what mdoc does, right? It's going and it's reading this file. It's doing something called parsing, if you're familiar with the term. Reading the file and kind of splitting it up into blocks of stuff which are just blocks of text or strings and blocks of code. It's taking all those blocks of code and it's running them in some execution environment. So it has the concept of a structure here, right? Our documentation has some kind of structure.
Done.
So we can run the code. We know the code has structure. The output we have is just really text, right? It's just a string, as you saw, and that goes back into the file. But is it possible for the other blocks, which are just the text blocks, to have some structure too? And in fact, they do. So if you take a look at Markdown, this is an example of a tree explorer. If you take a look at Markdown, you'll see that, well, okay, there is some structure here. There's a heading, there's a paragraph, there's a code snippet. And so we can actually take our Markdown and convert it into this tree structure. Now, if you use Markdown, pretty much every tool that you're using will be doing this under the hood. It will be building a tree structure of what that text looks like in terms of headings, paragraphs, lists, and it will be manipulating that structure. And in fact, the thing that we end up with is also a tree, right? Because if we are ending up with HTML, HTML has a tree-like structure as well, right? So if we start with this snippet of Markdown, we end up with this tree-like HTML structure. Okay, so that means that there are other things going on as well. There's not only this pipeline of just creating an artifact in the end, we also have some idea of parsing stuff into a tree and manipulating a tree. But there are even more ways in which they're kind of similar. So docs are also interactive, or at least they can be. They can be interactive, right? Dare I say it, do they have a runtime? Is that how we should think about interactive docs? So a really great example of what I mean by interactive documentation are Livebooks. Who here has used Livebooks? A few people, not that many. Okay, you guys, you should all use these. These are amazing. Okay, so Livebooks are a tool. They're a tool primarily for Elixir. You write in Markdown if you want. By the way, you can also use a different editor. And so here you can see we've got some Elixir code snippets. You might think, okay, this is going to be really, really similar to something like mdoc, like the documentation tools we've seen so far. But actually, Livebooks are much more similar to interactive notebooks. So if you've ever used something like a Jupyter notebook, where you can actually interact with code, that's what Livebook gives you. So it's an environment that this piece of Markdown is actually being run by, or rather the code snippets within it are being run by a server. And you can go and you can edit the code snippets and rerun them. So here is an example. Let's see. Let's hope that full screening doesn't break everything. Yeah, we're good. So, okay, we can evaluate some snippets here. We're evaluating some snippets for cat photo. And the interesting thing, okay, there are a few interesting things actually. So one is that we can navigate to documentation within this editor. And we can also edit the code snippets. So this is as a user, I can go in, I can go and edit these snippets, and I can reevaluate them. So not only can I just read something that is static, right, which is describing my library, I can actually interact with this library.
Bird.
There are other things that we can do as well. in the same way that we could use mdoc to display an image, we can use Livebook to display custom visualizations. And so to do that, we write some code. Oh, hold on. Let's full screen this. There we go. So to do that, we can write some code. So this is some code written in Elixir using a library called Kino. Kino is the thing we use to produce these visualizations. This is kind of similar to the modifier that we saw with mdoc in that it takes the output value that we got from executing a snippet and decides what to do with it. And in this case, what we're going to do is that we are going to insert an image. We're going to assume that the thing that we get in is actually a photo album, so a map of all of the images. We're going to see if we can draw all the images. We call this thing cat photo. Let's see if we can. Can we actually run it, the code that we've just written? So we've just wrote that cat photo thing. And if we run it, we see that it does, in fact, display our images. So it displays the images that we just inserted into our album. Cool. So that's using Livebook. One of the downsides, I think, to using something like Livebook is that your users will need to have it running, or they will need to have some kind of an account with, let's say, some Livebook server provider, right? Some cloud provider. So what that means is that there's a kind of a slight barrier to entry to, for instance, you guys, right? If you've not used Livebook before, you can go and you can read the Livebook documentation, but you need to take a few steps before you can start playing around with Livebooks. But wouldn't it be great if we could actually just have our documentation in the browser, right? So in the browser, meaning that for all of our users, they would be able to go and access it without needing to make some account or go to a server. They would be able to run it locally within their own browser. And these days, actually, a lot of languages compile to JavaScript. So it might be that you actually have a library, right, inside your own language, which you can compile to JavaScript and therefore run in people's browsers in kind of the same way as what Livebook is doing. But instead of needing a server, they can actually run it just by themselves. Scala is one of the languages in which you can do that. So you can take some library written in Scala, you can, with a tiny bit of effort, publish it to JavaScript. So you'll get, using a tool called Scala.js, some JavaScript. You can write some documentation, maybe you write that in Markdown, and that gets converted into HTML, and you can embed the JavaScript of your library into that HTML to get runnable code snippets. And that will get served to somebody's browser. So here's an example of this in action. So this is using, cool. So this is the documentation for a library called FS2 in Scala. The tool is the one that I'm working on. And what it does is that it runs this Scala library, which is about stream processing, and is about stream processing in Scala, but it runs it in your browser. So you can actually go to the Aquascape site, and you can play around with some of the interactive visualizations. So here we have some code, right? This is Scala code compiled to JavaScript and running in the browser. We have a form element, which controls this number n. So you can go and change this number, and what's going to happen is that there'll be some code running in your browser, which will run this code here, and also produce this visualization. So what's really nice about this, right, is that not only is it a great way to expose your library to other people in a way that's really accessible for you as a developer, you also don't need to worry about them completely messing up your server, right? So like the first thing that we want to do, right, as devs, is that we'll go to something like this and, whenever I show this tool to people, they try and type like 1 million into this box, right? Like, I would do that too if I was them, right? Like, you can't blame them. But the thing is, the only person they're going to upset is themselves, right? And that's very, very satisfying to me. So I strongly encourage you to play around with that idea. Now, there are some other really exciting tools in the Scala space as well. This is very, very much a POC one, but I wanted to show it to you anyway. It's called the Scala Explorer. It's being worked on by me and a few people in London, in the London Open Source Hack Nights. So if you want to start contributing to open source in Scala, you can come along to those. And what it does is that it's in the browser completely. The Scala compiler does not run in browser, but the parser does, or at least a parser does. So what that means is that you can actually write some code in Scala code in your browser, and that can be parsed inside your browser into some tree structure. So what we're doing here, right, is that we are writing some code. This is being parsed, and we're getting some definitions, right, of what we've just written. And we can actually go and navigate to the documentation for those definitions. So for instance, let's say you don't know what a class is, right? Or you don't know what a singleton object is. You can go and you can click on these links and you can go to the documentation of what those things are. And that's really nice because for some of these languages that we work in, a lot of the stuff is based on, very esoteric symbols, right? Or it's very contextual, right? So you can't really easily just go and take some code and just, paste it into Google, get an answer on Stack Overflow, ask an LLM, right? You often won't get the right answers. But in this way, we're actually producing a tree structure, and that's the thing that we're using. Okay, so we've seen how docs are, what are they? They're artifacts, right? We saw how we could put a pipeline together for our documentation to validate it. We saw that docs were like trees, right? Or they are trees. They have tree structures. And we've also seen that they're interactive. We can kind of think, if we're looking at our documentation and we're building stuff for JavaScript, we can kind of think of it having some kind of a compile time and then a runtime stage as well, where the runtime is in our user's browser. So our docs programs, if we take a look at the markdown that we wrote, and we're using mdoc here, so we're compiling some stuff in our code snippets, we're running our code snippets. When we're doing this, do you feel like you're programming when you're writing documentation? No, we don't, right? Like it's some people might think, oh yeah, maybe this is kind of similar to a programming language, but ultimately, right? Who wakes up on a Saturday morning and thinks, you know what I'm going to do today? I'm going to write some generative poetry. I mean, I do that, but I don't think, and I'm going to write it in mdoc, right? With markdown, right? That's not the language I would use, right? It's just not satisfying. Okay, why is that? Why is it not satisfying? Well, I mean, there are all sorts of different reasons. We can take a step back and we can take a look at the more the formal aspects of programming languages, right? We can say, okay, well, there's no real semantics associated with this thing. There's no real calculus there. That there aren't clear rules which I can use to express myself. But to try and explain why that's important, I'm going to give you a very specific example of something that we can't do with these tools. Let's imagine that for cat photo, we decide that we are going to have some credits. We are going to thank all of the cats that appear in our docs. Okay? You've seen two cats, by the way. Mao was my own cat. He's the sort of grey-black one. Popcorn is another very cute cat. We need to thank them. And every time we reference a cat in our docs, they need to be credited on this page. This is an absolute requirement, or we will get scratched much. Okay, so let's say that now we change our getting started guide, we add some more bits, and we say, okay, this is how you add a photo for Cinder, a new cat. We haven't thanked them. Well, this is a bug, right? It's a bug that we're not going to be able to pick up using the tools that we have. Now, let's take a step back and let's think, okay, well, if this was actually a programming language, right, and if we were writing a program, how would we solve this? Okay, so maybe one way of thinking about it might be that we would have this thank you file, and that would have a list of all of our cats, our allowed cats. And every time we had another file, that would maybe depend on our thank you file, our thank you source code, right? And it would query that list of cats for validation, right? So that's how we might solve this if we were writing actual code, right? We also might have some utilities for validating cats. Now, we can't do that in Markdown, right? We can't. Or can we? Can we? All right. We're going to see kind of a way to getting to this kind of validation, but also method of expression, right? Let's start with our HTML. All right, this is the tree structure that we end up with. And I'm going to change the angle brackets to round ones. And I'm going to get rid of the end tags. And does this look like a language to anybody? Yeah. This this is very, well, it basically is a Lisp. Depending on what you evaluate it will actually produce an output. So the language we're going to use to solve this problem is Racket. Your very well-known documentation language, Racket, right? So here's a quick intro to Racket. We know it's a Racket file because it has this lang Racket, and we give it the extension RKT. The lang is important. It kind of tells Racket how to interpret this file. This is how we might define let's call it a variable, right? My cat in Racket. We're defining it to be the string. This is how you define a list. A list is defined using braces. Oh, and this little apostrophe symbol. We're not going to go into detail into that too much. And this is how you define a function. So this is the function stroke. We use braces to call the function as well. Don't worry, right, if this is the first time you've seen Lisp, if you're overwhelmed with all the braces, you won't need to read it too much. We'll go through it very slowly, and there won't be too much Lisp code. Okay, but this is a programming language, right? We can evaluate it. So I can go into my Racket REPL. The way that I evaluate this code is that I import the file. And then I can refer to the variables, like my cat here. And I can also call the function. So I can call the function stroke to say stroke my cat, and I'll be stroking Mal. He'll be very happy. Okay, so well, that's same as you can do in other programming languages, right? Like you can write this code in Scala. You could write this code in Elixir. What's special about Racket? So Racket is a really great language because it is a language that you actually use to write other languages. In particular, you write things called domain-specific languages. You can, in Racket, very easily write your own parser, tokenizer, interpreter to interpret a language how you like. So here is an example, actually, of a language which is written in Racket. The language is called Pollen. And it looks very similar to Markdown, right? So it looks very similar to Markdown. The only difference is that there's this #lang pollen at the top. But it is a programming language. And I know that it is a language because I can evaluate it. So what I can do is that I can go into my Racket REPL and I can require this file just as I required the other Racket code. And I get some symbols out. I get a doc. And if I have a look at that, I get this structure with round braces, which is like a list. So tree-like structure, really, corresponding to the markdown that was inside it. And I can take that and I can convert that into a HTML string, which will be just what you will end up with in your HTML source file in the end. Okay, so that's really cool, right? I can now evaluate my documentation. And that means that I can do other things with it as well. So let's write some Racket code, right? Which goes and it imports that thank you file. Let's see if we can write that validation utility that we wanted in the first place. We can get all of the list items inside our document, and that'll be our list of cats. And we can write some validation function, we'll call it cat name, which checks if a cat is within that list. And if not, then it will raise an error. So the next thing to do, right, is to call that function inside our getting started file. And previously we thought of this as just Markdown, but now we really do think, okay, we are calling functions, right? We can require, right, import our catname file, and we call the function catname. There's this fancy symbol here known as the lozenge. Maybe typing this symbol is probably the most difficult thing about Pollen. I recommend you bind it to some keyboard shortcut if you choose to use this language. You know, as for why would you use such a really strange symbol that nobody would ever want to type? If you already play around with parsers for a bit or write custom languages specifically for these, you'll kind of understand that no, you really do want a symbol nobody is ever going to type, right? Cool. So if we run this code, right? If we run this code, we get an error. A cat wasn't thanked, right? Cinder wasn't thanked, and that's great. That's exactly what we want. So this is what now our actual our files look like, right? So we have our thank you file, which has the extension PMD, but this has something that looks very similar to Markdown in. Right? We've got our catname Racket file, which pulls that in, and we have our getting started file, and maybe all of the other bits of our documentation, those can go and reference catname. Now, it's really hard to describe the power of this, right? Because ultimately now, if we use this kind of model, we can create all sorts of different forms of documentation. We can solve many more problems within our documentation. So here's just a quick example of something that I wrote in Racket with Pollen. Actually, I wrote this years back, of a code reader. I hope you can see it. So what we're able to do is that we're able to click through little bits of our code snippet, and different ones are highlighted, and we have a little piece of text at the top explaining what it does. Now, the thing is that, yes, you could probably do this in JavaScript or using some other pipelines, but it was actually very, very easy to do it in Racket using this concept of docs as programs. Okay, so we've seen how docs are artifacts, right? They are trees, they're interactive, and they're also programs too. Oh. But you're probably wondering, okay, where next, right? What do you do with all this information now? Do you go play around with Racket? I really hope you do play around with Racket. But maybe even if you don't go that far, right, at least at the very least, start validating your documentation. So use tools like doctest and mdoc. Start using Livebook a little bit. It's really good for data exploration. So maybe start with that, and then maybe you might want to think about it for building documentation. Explore JavaScript pipelines. I'm really, really looking forward to, by the way, the kinds of creative documentation people will produce once they start thinking about it in this way, right? We will be able to see, hopefully, a lot more visual documentation associated with functional programming, more accessible explanations. So if you want to explore some more, there's a great paper which is on actually the calculus of documentation languages. Please check it out. There's also a book on Racket, beautiful Racket. Here are all the tools that we referenced. And you can find me on, well, mostly LinkedIn, but also Blue Sky. If you're interested in stream processing, there's a book, Early Access, which I'm currently working on. And also, I'm giving a talk at the Scala meetup tomorrow. So if you're interested in Aquascape, come to that. Cool. All right, thank you very much.
Thank you.